Alright, welcome back guys. Welcome to our third Algebra 1 tutorial series. Today we'll be talking about equations. So let's first and foremost start off by defining what an equation is. So based on our definition up here, an equation is a statement in which the values of two mathematical expressions are equal, and this is usually indicated by an equal sign. So let's go into what that means. So I'm going to give you guys a few examples of equations. So suppose we're given 3x plus 1 equals 7. Right? In this equation, we have two things that are equal to each other, and they're connected by an equal sign, which makes it an equation according to our calculations. Now we have 3 plus 3 equals 6. This is also an equation because we have two different sides that are equal to each other, which makes it an equation just like last time. And how about this? 3x squared minus 2x plus 1 equals 12. Although this may just be looking like a really long quadratic equation, it is still in fact an equation because we have two sides that are equal to each other, right? So I hope you guys have at least based with this a basic understanding of what an equation is. So now we're going to go into trying to solve equations. In our next video, make sure to watch that. We're going to show you guys how to in-depth solve these equations. Right now, I'm just going to show you guys how to visualize how equations work. So I have two examples I'm going to start off giving you guys. Suppose we're given the, let's mark this with number 1. Suppose we're given, let's write notes out. Suppose we're given the equation 6 times 5 plus 2, and then box 8 times 4 plus 5 times 2. Okay, so to solve this equation, you should at least try to watch my order of operations video, because that will come in really useful when trying to solve these. If not, it's fine. I'll just try to teach you guys a little bit as we go on. So as you guys should remember from last video, the way we solve these equations are by using PEDMAS, which is parentheses, exponents, multiplication and division, and then addition and subtraction. So first, let's go over here, and we see we have parentheses, so let's solve the parentheses first. And remember from last video, whenever we have a number touching, a coefficient touching a parenthesis, it just means that number multiplied by whatever's in the parentheses. So let's go over here. So we're going to have 6 times 5 times 2. Once we solve the parentheses, we get 7. We're going to put 7 there. Put the box over here to try to figure out if it's like equal to, greater than, less than, greater than, equal to, less than, or equal to. Just check it out. And then, just based on order of operations again, we're going to do 8 times 4 first, because on the left-hand side, which is 32 plus. And then let's just solve this also in the same step. 5 times 2 is 10. And then once we solve these both at the same time, 6 times 7 is 42. And box 32 plus 10 is also 42. So now when we look at this, we can just realize 42 is equal to 42. This is indeed an equation since they are both equal to each other. Okay, let's try out another equation. What if we're given the equation? This might seem a bit daunting at first, but don't worry, it's pretty simple once we get through it. Suppose we're given 8 squared, oh this is equation number 2, by the way. Suppose we're given 8 squared minus 24 divided by 2. We're going to have the same box from last time. And then we're going to have 5 times, if you guys don't mind, I'm just going to write my 5 my multiplication signs as dots, just how I grew up doing it. 5 times 3 plus 8 minus 3, okay? So let's start off doing PEDMAS again on this side. First we have to solve parentheses, we don't have any. We're going to go on to exponents since we have 8 squared. 8 squared is basically the same thing as 8 times 8, which is 64. We're just going to write 64 minus 24 over 2. We're going to draw a little box again over here, and then let's do our PEDMAS again. we see how we have no parentheses, we have no multiplication. So now let's look for our multiplication and division. We see we have 5 times 3, that's our first one. We're going to solve that straight out the gate, giving us 15 plus 8 minus 3. Now since we have this on the top, we're just going to solve this thing on the top. I know division comes first, but when we're trying to solve equations like this, we always try to get the numerator as simplified as possible before dividing. Alright, so let's do this. 64 minus 24 is 40, divided by 2, box, and then we have 15 plus 8, which is 23, minus 3. Oops, it's not a 4, it's a 3. What am I doing? 23 minus 3. Continue that over here. 40 divided by 2 is 20, box. 23 minus 3 is 20, and 20 is equal to 20. This is indeed, draw a check mark over here, an equation. Oh yeah, and going back to this thing over here, why I didn't do division first before subtraction, I just wanted to say, since it's two numbers being subtracted by each other anyway, it'd be the same exact division anyway. Because suppose we did 64 halves minus 24 halves, that'd be 64 halves is just 32, and 24 halves is 12, because 12 times 2 is 24. 12, and then if you subtract those out, you'd still get 20. So we get the same number anyway, even if you did either way. But yeah. Okay, so those are two basic examples. Let's try to get through at least one more example over here. So suppose we're given 3 times 5 plus 2, and put the entire thing in parentheses, and then square it. Draw a box, and 15 on the other side. So how do we go about this? So we know parentheses are first in PEDMAS, and we know we have to solve everything inside the parentheses. So we already knew that. We're going to solve the parentheses first. But now that we know we're going to solve the parentheses first, and we know exponents are second, we're going to try to solve the parentheses first, still using PEDMAS. So we don't have any other parentheses inside this parentheses. We don't have any exponents inside the parentheses. So we're going to check for multiplication and division. And when we check, we do have multiplication. So we have 5 times 3, which is 15, plus 2, which is 17. You know what, guys, for the sake of the example, I'm just going to make it a bit easier. Make this a minus 2. That's okay with you guys. Otherwise, just have to go get the calculator out, and it's a big deal. 15 minus 2, and that's squared, box, 15. Now, once we do this, we have 15 minus 2, which is 13. Now we put the exponent on it, and 15. And we know 13 squared is 169, box, 15. Now when we look at this, we know that it is not equal, so this is not an expression. To write not equal, just draw an equal sign and draw a backslash right over it, okay? So this is not an equation. Okay, let's go on over here. So our next example. Now that we know how to do these basic examples, let's try to do practice problems that are a bit different. Suppose we're given 5x, okay, you know what, I'll draw this a bit neater. How about we're given 5x plus 24 equals 49, okay guys? And we're given 3 numbers, 1, 5, and 9. So suppose we're asked to get the value of x. So what is x equal to? So we know that we have to try to get this one side equal to the other side. So how about we just try plugging in our values until we get one equation where we have one side equals another side. So let's start. This may be like a harder way of solving equations. In our next way, I'm going to teach you guys a really quick, easy, and simple way for solving equations using properties of equality. Okay, guys? Beware for that. So let's start with our first one. Let's plug in the number 1 for x. 5 times 1 plus 24 equals 49. We know that 5 times 1 is actually just 5, so we're going to have 5 plus 24 equals 49. And we have 29 equals 49. This is definitely incorrect because 29 is actually 20 numbers off, 20 digits off, whole integers off. Okay, enough of that. Okay, so suppose we're given 5, and then for x this time, suppose we put in the value of 5. 5 times 5 plus 24 equals 49. Suppose we do this, we're going to have 5 times 5, which is indeed 25, plus 24, right guys? And then when we add 25 and 24 together, we get 49. So just put these together, 25 plus 24, if you guys want to visualize it, 25, 24, plus sign, 5 plus 4 is 9, 2 plus 2 is 4, now you get 49. So the answer to this equation would be 5. Okay guys, so I've also prepared another example for you guys to try out on your own. Suppose you're given 3x minus 3 equals 24, and you're given the values 3, 4, and 8. What is the value of x? So you guys really try pausing this video. It's really going to help you out if you guys can do this on your own. Try pausing the video and solving this on your own once. If you're unable to solve it, just unpause it and I'll be right here with you guys and I'll just help you guys solve it. Okay, so hopefully you guys have at least tried the video at this point. Tried the problem at this point, not the video. Hope you guys have at least tried this problem once at this point. So, and now we're going to go through it together and I'm going to explain to you guys how to make this work. So number 1, we're going to draw this and we're going to plug in 3 for x this time. So we know, actually, you know what? I'm going to teach you guys a little easy strategy for these kinds of problems. So let's try to plug in the number 4 because this is going to be a really smart reason for this reason. So since 4 is the number in between 3 and 8, if we know that this number is if we know when we plug in 4 our answer is too small, we're going to decide that the answer must be 8 because 8 will be a number that will be bigger and 4 is less. But if our answer is too high, we're going to know that our answer is supposed to be 3 because even if we plugged in 8, our answer will end up being higher. If that did not make any sense to you guys whatsoever, I'm about to show you guys what I mean. So suppose we plug in 4. Suppose we plug in 3 times 4 minus 3 equals 24, right? Suppose we plug that in. Now we're going to get 3 times 4 is 12 minus 3 equals 24, right? So 12 minus 3 is equal to 9, and 9 is not equal to 24, which makes this is not an equation, right? But, okay, so if we know that 9 is too small, and if we know 4 is too small of an answer for x, and we know that 3 would be make x even smaller, giving us an even smaller answer, how about we try plugging in 8 this time, because this would at least give us a bigger value. So when we plug in 8 for this one, we're going to get 3 times 8 minus 3 equals 24. When we do 8 times 3, we get 24 minus 3 equals 24, right? And then when we solve it, we have 21 equals 24. Okay, so when we solve this, we see that 21 equals 24, and 8 is also too small, which means that this is most likely not, means this is not the answer. So if 8, which is larger than both 3 and 4, is still too small, then chances are none of ours are actually the right answer, and none of these solutions are none of these are solutions to the equation. So if you guys wanted to see what 3 would look like, I'm just going to copy this equation onto another slide and show you guys. 3x minus 3 equals 24. And suppose you guys wanted to plug in 3 for this, we just get 3 times 3 minus 3 equals 24. And 3 times 3 is 9, minus 3 equals 24, and we'd get 6 equals 24. Oops. 6 equals 6 would make it true. That's not what we have. 6 equals 24, and this is not true, so just draw the not equal to sign. Yeah. 6 is not equal to 24. So as you guys can see, when we plugged in 3, we got 6. When we plugged in 3, we got 6. When we plugged in 4, we got 9. And when we plugged in 8, we got 21. Right? So this just comes to show why we should have tried plugging in 4 first. Since we plugged in 4 first, and we knew that 4 was too small, we knew that most likely if 4 was too small, 3 would also be too small of a value for x. That's why we decided to go plug in value 8. When we found out the value 8 was also too small, we decided there was none of these equations would actually be, none of these solutions would be solutions to this equation. Okay, so hopefully you guys learned something. If you did, make sure to leave a comment and like down below, and I hope to see you guys in the next video. Peace.